Here in example 2, we want to do two things. Okay, so we are asked to, first of all, complete the square. Secondly, we want to find the roots of the equation. So this is a two-step question. A lot of work going to be involved here. You'll notice that off the bat, the question I have is not a simple trinomial like we just did in the previous example. Okay, it does have a 4 in front of the x squared term. So, I mean, technically, we don't know how to do this. Although in the next example, we'll learn how to complete the square with a coefficient other than 1 in front of the x squared term. But as always, just like in factoring, you should always be trying to divide out a common factor. You'll notice that all these terms, let me zoom in here, they're all divisible by 4. Okay? And what I'm going to do is rewrite that equation. I'm going to rewrite the equation over here in such a way that I have a 4 in front. So I get x squared plus 10x plus 70. And I'm going to complete the square using the process above with the trinomial that's inside, because this is now a simple trinomial. The 4 in front, well, I'm just going to leave it there. Just ignore it until the very end when we bring it back in. So I have the 4. Step number 1, I put brackets around the first two terms. Step number 2, off to the side, and I'll do this in red, I take the coefficient of the x term, that's the 10, I divide it by 2, which gives me 5. I take the 5 and I square it, and that gives me 25. So that's the 5, square it, and that gives me 25. That 25 now goes into the equation as such. Inside this inner set of brackets, first of all, I add 25, then I subtract 25. And I got that plus 70 at the end, close bracket. And in my next step, that last negative 25, I'm going to take outside the innermost brackets. So I get a negative 25 out here, plus 70, close brackets. Now to save me some space, because space is at a premium, I got some more stuff to do in this question. I'm just going to combine these together here. So negative 25 plus 70, if I add them together, I get positive 45. Lo and behold, what you're left with here is a perfect square trinomial. You can just rewrite it as x plus 5 squared, then the plus 45 here, close bracket. And one final step, because that 4 was factored out, I have to bring it back in. So I have to multiply it by the first and by the second. Just clear up things here. So my final answer in vertex form will be 4, x plus 5, don't expand this because it is vertex form, plus 180. Because 4 times 45 is 180. So that completes the first part. Let's take a look at what's going on here. For the second part, I want to find the roots. Now remember, the roots are, this is a parabola. Notice that it has a positive 4 over there. So that means my parabola is opening up. So I'm going to have a root here, and I'm going to have a root here, if indeed it has any roots. I don't even know yet. But the roots are where the parabola intersects the x-axis. In other words, in this case, in these cases here, we know that y will be 0. So if I go to my equation and try to make it so that y is equal to 0, here's what I get. Let me use my vertex form. I get 0. 0 equals 4, open brackets, x plus 5 squared plus 180. So all I did was copy the last equation of my work here over here, okay, and set it equal to 0. Now, I'm looking to solve for x. So, I'm going to bring the 180 over, and that becomes negative 180. Already, I have a premonition that this is not going to turn out the way I want it to, okay? Not because we're wrong, but because this has no roots. I divide both sides by 4. Remember, I'm trying to isolate for x. And what am I left with? Negative 45 equals x plus 5 squared. At this point, you should stop, not go further. Why? Because is it possible, whatever this number is it possible to square a number and end up with a negative? Clearly, the answer is no. Okay, and what does that mean? Therefore, there are no roots. And in terms of my graph, well, it's opening up. There are no roots. The only way it can possibly look like is not like this diagram here, but like this. Somewhere up there. No roots, opening up, going to infinity, never crossing the x-axis. So there is your example number 2. Next, we're going to look at completing the square where we have an a value different than 1 in the front.